Hello and good day. I'm Ming Choy, and I'm here today to present for my PSM 1 thesis. So first, my title will be Solar System Exploration with Hand Gesture, and my supervisor is Dr. Nur Zuraifa Shazra binti Othman. Next. Next will be the introduction. So in the introduction part, I've introduced science and its related role and the important fields in science. And I've also introduced solar system, the naming, including its naming and definition. And lastly, I have also introduced leap motion controller and the hand gesture interaction in general. Next will be the problem background and aim for the project. So the problem background will be first, a livelier visual communication method can be explored and make use of to make the online class enriching and fun. And second, students frequently find it hard to comprehend with the spatial concepts and phenomena of solar system when given only through text or 2D representations such as static image. So the decrease in enthusiasm for learning causes students to find the topic boring and difficult to focus in the class. They are able to interact with content, which is the solar system, with their own hand making the learning process more fun and understandable with the development of this project. So the aim of the project is to develop a simulation of solar system using leap motion. So there are three main objectives of this project. First is to study the related user interaction requirements and technique for developing the solar system exploration application for the lower secondary school students. Second is to design and develop a solar system exploration application for the lower secondary school students by using the leap motion device. And third is to evaluate the capability of the solar system exploration application in enhancing the students' learning experience on the topic of solar system. The projects, there are five main project scope, which is first, the target user of the application is focused on Form 2 students who are learning solar system topic in their science subject. Second, the subtopic for the solar system that will be covered in this application includes the characteristic of the planets in the solar system, direction of planet rotation, and natural satellite, which is the moon. And third, the application will track and recognize the hand gesture of a single user at a single time. And next is to utilize the hand gesture tracking in leap motion. And lastly is to track all type of hand gesture that are required for the application. The importance of this project is first to help the user to understand the topic of solar system in a livelier method. Second, to making the content of the topic solar system more understandable and fun in learning for the student. And third, to form interest within students in solar system and also science in general. So I've made some comparison on the existing system, which is the Leap Motion Interactive Solar System and NASA Overview Solar System. So in terms of NUI, the first existing system uses hand gesture as input, while the second one uses mouse as input device. And the function of the application, the first existing system is the user can align the planet, rotate the planet, zoom in and out, and reorbit the planet. While for the NASA solar system, the user can view the inner and outer solar system, view each terrestrial planet in solar system, and also have comparison mode to see the ratio of the size of two different planets. So in terms of content provided, the first existing system, which is the Leap Motion Interactive Solar System, the content is sufficient but not so detailed since some general characteristics of the planet are not focused as the main content. While for the NASA solar system, the content is interesting and sufficient and provide detailed characteristic and information on the planet in solar system. These are the picture of the two existing systems. So on the left is the Leap Motion Interactive Solar System, and on the right is the NASA Overview of Solar System. So for this project, the main methodology will be using the waterfall model. So for waterfall model, there are four main phases as shown in the figure. So this project is delivered in a sequential order and cannot intersect among each phase. So the four phases are analysis phase, design phase, implementation phase, and also the testing phase. So this project suits for the waterfall model because it's a small scale project which only requires one developer for production. And also the waterfall model is the easiest model to manage and compatible with the fast delivery of this project, since this project has a short period. Next. So the technology used will be, first for game engine will be Unity 3D game engine, and for gesture input device will be the Leap Motion hand tracking device. And next will be the hardware and software requirement. So first we'll talk about the hardware requirement. As shown in the figure, the hardware requirement are the laptop model of Acer Nitro and the CPU of Intel i7 and GPU of NVIDIA GeForce GTX 1650, and the RAM is 8 GB. And other hardware required are the Leap Motion controller device. And for software use, the operating system is Windows 10, and the software used for development is, as mentioned just now, Unity 3D version 2019.4.33F1, and also Visual Studio 2019 for coding. And the SDK used in Unity are the Leap Motion SDK, which is compatible with the Leap Motion hand gesture tracking device. Next will be the use case for the solar system application. So for the use case, the main use case are divided into two, which are the control application and explore solar system. While respond to the hand gesture interaction and navigate between the interface are the use case which have an include relationship with the two main use case. The two main use case is shown as in the figure here. Next. Next will be the system framework of the project. So the system framework of this project consists of 5 main components, which are the user, Leap Motion SDK, solar system exploration application, and also the display. So first, the user will implement hand gesture as input to the Leap Motion device and receive the output from the display. The input by the user will capture by Leap Motion controller device, and the data captured by the device is then accessed and controlled by using Leap Motion SDK in Unity. By analyzing the capture device from Leap Motion, the application will present the output onto the display, which is the screen of the laptop to present to the user. Next. Next will be the hand gesture design. So for the start menu, the gesture will be the tap, and is to tap on the start and quit button to navigate to the main interface and also to exit and terminate the application. Second will be on the main interface, which has held up and held down hand gesture, which is to zoom in and out in order to navigate to the start menu interface and also to load the detail view interface. Next is from the detail view interface, also held up and down to zoom in and out to navigate back to the previous interface and also to the next interface, which is the main interface. The planet view interface. And next, the planet view info interface also has held up hand gesture to zoom out to navigate back to the planet view interface. For the planet view interface, there are 5 types of main hand gesture, which is held up, down, tap, and left and right swipe and left and right rotate in order to navigate to the different interfaces and also to view and rotate the planet. So these are the interface design of the project, which are the interface mentioned just now. All right. And next, these are also some of the interface design. Lastly, as conclusion, this project is expected to achieve all the objectives stated, which are to study the related user interaction requirement and techniques for developing solar system exploration application for the lower secondary school student, and also to design and develop a solar system exploration application for lower secondary school students by using Leap Motion. And lastly, to evaluate the capability of this system in enhancing the students' learning experience on solar system topic. So the main constraint of this project will be the overheating of Leap Motion device, but it can be overcome by taking cautious steps. So the main plan for the PSM2 project will be to execute all the graphic user interface, which is the GUI, successfully, and to ensure the implementation of gesture interaction with the use of Leap Motion controller device is successful and does not contain any technical issues. That's all for my presentation. Thank you.